I had a moment yesterday that, well, it just perfectly framed what we're doing today.
Oh, yeah?
I was staring at a raw data dump, just a massive scrolling wall of text and numbers, and for a solid minute, my brain it refused to engage. It was pure noise. But then, slowly, I started picking out these little islands of meaning. Okay, that block is a timestamp. That sequence there is a user ID. That's a price. I wasn't understanding the story of the data yet. I was just identifying the pieces.
That is exactly the mental shift required for this week. You were essentially performing manual lexical analysis. You were scanning a stream of raw characters and grouping them into tokens.
Tokens, right. These meaningful chunks that the brain, or in our case, the computer, can actually work with.
Exactly.
And that is the mission for this deep dive. We are tackling Lab 2, Make and Flex for the CS330 Programming Languages and Compilers course. We've spent the last few weeks looking at the theory, the high-level concepts. Now we have to actually build the machinery that does it.
This is the rubber meets the road moment. We're moving from the textbook definition of a compiler to using tools like Flex to, actually generate one.
And we've got the Lab 2 briefing notes, the team assignment details, and the updated homework schedule right here in front of us.
But we aren't just reading instructions here.
No. We need to figure out why this lab is structured the way it is. We've got a calculator that breaks the rules of math, a slang translator that struggles with the word twirl,
and a Git submission process that is honestly stricter than some bank security protocols.
It does feel that way sometimes, doesn't it?
It really does. But every single constraint in this lab, from the file naming to the specific Git tags, it's all teaching a specific engineering lesson. This isn't just about getting code to run.
It's about systems programming and precise version control.
Exactly.
Okay, so let's start with the big deliverables. We have two distinct parts, a team challenge and an individual challenge. The team challenge is happening in the Lab 2 Flex Team directory. The goal sounds simple enough. Build a calculator.
A calculator, yes. But looking at the source notes, there is this massive caveat here that usually trips people up right out of the gate.
What's that?
The notes explicitly say this calculator need not respect PEMDAS.
Right. So usually if I type 2 plus 3, 4, I expect the multiplication to happen first. 3 times 4 is 12, plus 2 is 14. But here, the notes say we're just processing left to right.
Exactly. So in this lab, 2 plus 3 happens first, giving you 5, and then you multiply by 4 to get 20.
Which, to a math student, that looks like a bug, a pretty big one.
It looks like a huge bug. But in the context of lexical analysis, it's a specific design choice. We are focusing purely on the scanning phase, recognizing that 2 is a number, plus L is an operator, and 3 is a number.
So we aren't building the parsing logic yet, the syntax tree that decides precedence and order of operations?
That's a really helpful distinction. We're teaching the computer to read the words, not necessarily understand the grammar or the hierarchy yet. If we forced you to implement order of operations now, you'd be fighting with parser logic before you've even mastered the scanner.
So we're isolating the variable, so to speak.
We are.
But don't let simplified math fool you. The architectural requirements for this team lab seem actually quite aggressive.
They are. The notes are obsessed with modularity. It says each team member has to implement 2 unique mathematical functions. But you can't just all open main.c or the flex file and start hacking away.
No, and that would defeat the purpose of a team lab anyway.
Right.
The instructions require separate C files. The naming convention is strictly enforced as calcstudented.c. So if your ID is jdo, you are writing calcjdo.c.
And critically, you also need a corresponding header file, calcjdo.h.
So why is the course so pedantic about this? Why not just let them write a script or put it all in one place?
Because in the real world, compilers are massive pieces of software. You can't have one 50,000 line file. This requirement forces you to deal with linking. When you run Flex, it generates a C file called lex.yy.c. That's your scanner.
Okay.
But that scanner doesn't know how to calculate a square root or a logarithm. It has to call out to your external files.
So lex.yy.c is basically the traffic cop. It sees a token that says score RT and says, okay, I need to hand this off.
Exactly.
But it doesn't know where to send it unless you've set up those headers correctly.
Precisely. The scanner is saying, I see a square root request. Go ask calcjada.c how to handle that.
Mm-hmm.
And for that to work, you have to manage the header files correctly. You have to tell the Flex file, hey, these external functions exist.
And where does that go?
In the Flex definition section, that top part of the file enclosed in the percent brackets. If you forget to include the function declarations there, the compiler will just throw a linking error.
That's a classic, it works on my machine scenario waiting to happen. I wrote the function.
Yeah, but you didn't link it.
And that brings us to the collaboration aspect. You have multiple people creating multiple files, all trying to update the same Flex scanner to recognize their specific tokens.
Which is a recipe for merge conflicts if you aren't careful.
It really is.
And that's why the notes emphasize the collaboration protocol. You can't just hack away simultaneously. You need to coordinate who is adding which tokens to the Flex file. You are building a system of dependencies.
This segues perfectly into our next bit here, the collaboration protocol, or as the notes call it, submitting the team lab. This isn't a drag and drop a zip file situation.
Far from it. This course uses Git not just as a storage bin, but as the actual submission engine. And there are specific roles involved. The notes mention an understanding leader.
Which we know from the syllabus is the person responsible for verifying the team's work.
Right. But before we get to the leader, let's talk about the grunt work. I'm editing the code. I'm in CS330 Lab work. I finished my function, what now?
What's next?
You have to stage your changes. The command is git add, and I want to pause on that dot.
The trailing dot, it's such a small character, but the notes specifically call it out in the slides.
It's vital. Git add by itself often does nothing or throws an error. Git add tells Git stage everything in the current directory. If you miss the dot, or if you aren't in the root of your repo, you might think you've staged your work, but you haven't.
So you commit an empty shell, you push it, and your teammates pull down nothing.
Exactly. And it is incredibly frustrating.
I've definitely been the person asking, did you actually push? While my teammate swears they did.
Okay, so I've added with the dot, I've committed, I've pushed, my teammates use git pull to sync up. We've built the calculator, it works. We are done, right?
You are absolutely not done. And this is where I see students fail labs even when the code is perfect.
Oh, wow.
The submission relies on a git tag.
Okay, walk us through this. Why isn't the code enough? Why do we need this extra step?
Because a repository is a living history. It changes constantly. The grading script needs to know exactly which moment in history you want to be graded on. You have to place a marker. The command is git to a lab2 submission 1 emitter lab completed.
The AA stands for annotated, right? Yes. It creates a tag with metadata, who made it, when, and a message. It's more robust than a lightweight tag. But here's the catch. Creating the tag only happens locally on your laptop.
I can see where this is going. You make the tag, you shut your laptop, you go to sleep, and the professor never sees it.
Correct. You must explicitly push the tags to the server. The command isn't just git push. It is git push follow tags.
Follow tags. If you leave that flag off, the code goes up, but the tag stays behind.
Exactly. And the notes are binary on this. No tag, no email verification, no email, no submission. The understanding leader essentially has to press the big red button to launch the submission.
So if you are the designated leader for this lab, check your email. If you didn't get a confirmation, you didn't finish the git push follow tags step.
It's a harsh lesson, but it mimics industry.
Yeah.
If you don't cut the release branch correctly, the software doesn't ship. It forces you to verify your tools.
All right, let's pivot. The team has survived the calculator. Now we move to the individual challenge. We're changing directories to Lab2 Flex introduction.
And this assignment is a bit more whimsical, but technically, I'd say it's arguably trickier. You're building a texting slang translator.
The goal is to take input like ICAR or GA8 and expand them into, I don't know, or great. The notes say we need at least 10 terms.
It sounds easy. Just find ick and replace it. But this lab exposes a major limitation of Flex compared to modern programming languages.
Which is?
The word boundary problem.
The notes use the Twirl example, which I thought was great. If I'm translating Earl to in real life, I don't want the word twirl to become twin real life.
It's funny, but it's a nightmare to debug. In Python or JavaScript regex, you'd just use B. That's the code for word boundary. You'd say burl, and you're done.
It ensures there are no letters touching your target word.
Right. But Flex says, nope.
It just doesn't support it.
The notes state clearly, Flex does not support B. Flex is an old tool. It works on raw character streams. So you have to manually define what a boundary looks like.
So how do you solve that? You can't just match Earl.
You have to look at the context. You have to write a regex that says, I am looking for Earl, but only if it's at the start of a line, or end of a line, or surrounded by spaces or punctuation.
Wow, okay. That complicates the regex significantly. You're not just matching the word, you're matching the negative space around the word.
And remember, scanners are greedy. They will try to match the longest possible string. If you aren't careful with your rules, Flex might eat up the punctuation mark meant for the end of the sentence because it was part of your boundary check.
So there's a real risk of deleting parts of the user's sentence if your regex is too sloppy.
Exactly. If your rule says Earl followed by a space, and you replace it with in real life, you need to make sure you put that space back or account for it. Otherwise, you're altering the structure of the sentence.
And that brings up the output requirement. The notes say you should use print for the translation, but critically, output any non-matching text intact.
Right. If I type the weather is nice, the scanner shouldn't just denote it because it's not slang.
You need a catch-all rule.
A rule at the very bottom of your Flex file that says match any character I haven't already dealt with and just print it out as is. This is the default echo behavior.
So without it, your translator might just eat everything that isn't a slang term.
It would.
That would be a terrible user experience. I don't know, silence in real life.
Exactly. It teaches you to manage the flow of data. You are acting as a filter. Some stuff gets expanded, the rest flows through. It really forces you to think about every single character that passes through the buffer.
And just like the Keen Lab, this individual one follows the same GIP protocol.
Same dance. Git add doc, git commit, git tag, lab2 submission 1, and git push follow tags. If you master it for the team lab, the individual one is just muscle memory.
But you have to do it for both repositories.
Both repositories, correct.
Okay, zooming out, we're recording this on Tuesday, February 10th. Looking at the homework schedule provided in the notes, the deadlines are stacking up fast.
It's a heavy week. If we look at the upcoming homework section, the first hurdle is this Friday, February 13th.
We've got reading. Chapter 4 of the compiler's book.
And this is a signal. Chapter 4 usually introduces context-free grammars and parsing. We've been talking about lexical analysis looking at words. Chapter 4 moves us to syntax looking at sentences.
So if Lab 2 is spelling, next week is grammar.
That's the perfect analogy. You're going to need to understand how those tokens you're generating in Lab 2 fit together into a valid program structure.
There is also a second reading for Friday, the productivity paradox of AI coding assistants. This feels very relevant given the vibe coding policy we saw in the syllabus.
It is critical. The paradox is this. AI tools like Copilot help you write code faster, but they often introduce subtle, plausible-looking bugs. So you save time typing, but you spend more time debugging.
Bringing it back to the Twirl example, an AI might generate a regex for you that works 90% of the time.
Sure.
It might look at your prompt, translate Earl, and give you a regex that doesn't account for the lack of B support in Flex.
Exactly. And if you rely on vibe coding, just trusting the AI's vibe without understanding the underlying tool, you won't know why your scanner is breaking on Twirl. You have to build the mental model first. The AI can assist, but it cannot be the architect.
Then moving to Sunday, February 15th, we have the week 4 journal entry.
Remember the 2-1 rule. Minimum 2 paragraphs, 1 quiz question. The journal is your synthesis tool. Don't just write, I did the lab.
Right.
Write about the difficulty of linking C files. Write about the logic puzzle of the regex word boundaries.
It's essentially a log for your future self. Here is where I got stuck, and here is how I fixed it.
And the quiz question requirement forces you to think like the professor. If I had to test someone on this, what would I ask? That is a powerful study technique.
And finally, the main event, Monday, February 16th.
Lab 2 is due. Both the team calculator and the individual slang translator.
That means by Monday night, you need your code pushed, your tags created, and that email verification in your inbox.
And please, do not wait until 11:50 p.m. to test if git push follow tags works on your machine. The git dance takes time.
Oh, absolutely.
If you have a merge conflict 5 minutes before the deadline because you and a teammate both tried to add a square root token to the same line, you are in trouble.
So to recap the so what of this deep dive, we are taking control of the input.
We are. Whether it is defining a new mathematical operation or redefining it to mean, I don't know, Lab 2 is about defining the rules of the language.
Yeah.
You are telling the computer how to read.
It's a shift from being a user to being a creator. When you write a scanner, you aren't just processing text. You're deciding what holds meaning. You're deciding that this specific sequence of characters triggers this specific C function.
And you're learning that meaning in computer science requires strict structure from the regex patterns to the git tags.
Yeah.
You can't just have the idea of a calculator. You have to link the binaries.
I want to leave you with a thought on that productivity paradox. We're spending hours in this lab manually writing regex to catch Earl without catching Twirl. It's tedious. It's annoying.
It is. It feels like busy work sometimes.
But if we skip this struggle, if we just let an AI write the scanner for us, Do we ever actually learn to see the data the way the machine sees it, or do we just become passengers in our own code?
That's the danger. If you can't spot the boundary error yourself, you can't verify the AI. You have to know the rules before you can automate them. You have to know what a token is before you can ask a machine to find one.
A compelling reason to embrace the struggle of Lab 2. So, open up your terminals. Check your directory paths. Are you in team or introduction?
And watch that trailing dot on your Git add. It is the most important character you'll type today.
And verify those tags. Good luck with the calculator, have fun with the slang, and we'll catch you on the next deep dive.
Happy coding!